Good morning. It's excellent there's not that many of you today because I'll disappoint fewer people. So, my name is Rabbitson, or ribasushi as people know me on IRC. I deal with DBIx class most of the time and its ecosystem, more or less like SQL abstract and SQL translator and things like that. And today I wanted to give a talk about like very, very basic SQL for people who do not, feel entirely comfortable with it and stuff like that. How many here actually are comfortable with joins, for example, and stuff like that? What are you doing here? Okay. The other problem with this talk is that this talk is relatively cursed. The first time I gave it, basically my slides kind of cut off in the middle of my HTML and stuff. And since then I redid them entirely, and this morning while I was tweaking stuff here and there, my battery went out. And I run XFS on my laptop, and XFS does not like when the power goes out. So we will improvise a little bit. I have about 2/3 of my slides, and the most interesting ones are missing. So when we get there, we'll see, how we are on time and stuff like that. So maybe this presentation will be cut short, unfortunately. But, let's begin. So, SQL for accountants, understanding the beast via spreadsheets. I'll introduce myself. Oh no, and Tim is here. Come on in. Yes. Oh yeah, see, I put that in, before it crashed and took the rest of the slides with it. Yeah, how cool is that?
Rabbitson is misspelled. See, Rabbitson is misspelled.
It isn't. You suck. Right. So, SQL, structured query language. It is old and not very popular these days because old is how hipsters call everything that's useful and just works. And it is heavily standardized. It behaves absolutely the same on any RDBMS that you run it on. Not. And it is more or less hateful. Basically, it is a very expressive language in in a very limited set of keywords, and because of this expressiveness, it allows you to make mistakes relatively simply, and debugging it is pretty just hard because RDBMS are not very useful and giving you the correct reports on where you misstepped and something like this. But as I said, it's very, very, very powerful. So, a disclaimer. There is a bunch of, well, basically there is only one table that we work with, and there will be some basic SQL that will be shown. And there are at least 4 things that the first slide will violate right out the bat. So if you do this kind of stuff in your production, your managers will most likely beat you up with reason. So SQL, we have stuff called create, basically to make tables and to define what it more or less is, just a spreadsheet. Because all SQL deals with, it deals with 2-dimensional data. So you can think of it as this complicated thing with joins and with indexes and stuff like that. Or you can just say, what, it's just a collection of Excel spreadsheets in a workbook, so to speak. And we are going to look at it and query it back and forth and stuff like that. So for instance, here we're going to declare what we're going to work with. We create a spreadsheet or a table, the way we call it in SQL, called company. And it has 3 columns. And the columns will kind of always be there because just like in a normal spreadsheet, you normally have your columns fixed. And then you add or remove rows depending on how your data goes in and out. So it has, the first column is called employee. It can take up to 50 characters. The second one is called department, same thing. And experience, supposedly how many years did the person work in this company. And an empty table will look like this, or an empty spreadsheet. So you also can in pretty much any database, and this is one of the very few things that is more or less standardized, in almost any database you can execute this command, show create table and the name of the table, and you will get something very similar to this, which defines how the table can be recreated and what it contains. So let's put some data in our sample company. We have 3 distinct departments. The Java department is the biggest one, and it has some inexperienced people and some pretty experienced people. And we have a .NET department, and we have a Perl department with pretty much the oldest employees and the funniest names. So how do we update in SQL our spreadsheet? We use a command called insert. And the insert syntax is actually pretty simple. We say insert into where, which spreadsheet, so company. Which columns are we going to populate, because you can't have columns without, you can't have empty cells. And then we say which values we're going to put in there. So if we execute this stuff on top, we're going to insert this into the database. And it's exactly what we specified on top. Depending on how your table is created, it might allow you to, for example, drop the experience, and it will insert a 0 on its own. Or it might allow you to even drop the department. And if it doesn't allow you to do that, and you don't specify them in the values, it will throw an exception and say, such and such constraint violated and stuff like that. But again, this is very dependent on how your current database and tables are set up. So we're not going to delve into that. So before we go further, we need to talk a little bit about how in SQL we express a condition. So a condition more or less is like a bunch of ifs in any programming language, and it consists of simple building blocks, normally with a left and right operand, so just like A equals B. We have the regular logic comparison operator, so equals, larger than, smaller than, not equal. We have something like the Perl's equivalent of index, so which is called like in SQL, so it's like a limited regular expression. And we can combine those building blocks with the usual and or not operators, the usual logic. And we can use parentheses to denote our blocks and where and how things are, how to define precedence, what is ended with what, and so on and so forth. And the result is, just like in any programming language, we can build up arbitrary complex conditions. So for example, this is a simple condition of A equals B. So we take the column employee, and you check if it equals Java boss. And it will be satisfied for only rows in the spreadsheet which satisfy this condition. This is the limited regular expression I was talking about. Everything that ends in boss will match. This is how logic works. So we have one condition which needs to be satisfied, and another condition that also needs to be satisfied. So this will select all the bosses that are not Java heads. And this shows precedence. So we have one condition ended with either that condition or this condition. Pretty basic stuff. How we remove rows from a spreadsheet? We use the delete command. The delete command is different from the insert in terms of how the name of the table is specified. So in insert we had insert into company. Here we have delete from company. And we can add any kind of condition on the end, just like we specified on the previous slide. If we don't specify conditions, we just say delete from company, it will just blow away the entire spreadsheet. And it will keep the table in place, but it will be empty at the end. So if we execute this command, what's going to happen is it is going to match these two rows. Come on in. It will match these two rows because those are the only two guys with experience less than 2 years. And it will blow them away. So we're downsizing, we're firing our youngest employees. And the result will look like that. What else can we do? Well, we sometimes want to update stuff in our table or spreadsheet. So again, the syntax is in the standardized language different. For update, you only specify the name of the thing. You don't say update from or update into. You say update company. Then you have the operator set, which might take one or multiple columns. And you say, what do you set each column to? Now, we normally don't want to update entire columns. We want to update cells. So not only we want to say what are we going to update vertically, employee, but we want to horizontally select which employee of all we're going to update. This is how we're going to update a cell. So what's going to happen here is we are going to find the current employee, who is a Perl boss, right there, and it finds the row, and then it looks, okay, which columns do I need to set in this row? It's just employee. It will do that, and the result will look like this. So now our boss is called a lord or whatever. And I mentioned that we might want to update the entire table at times, but we don't really want to put the same value everywhere. This just, most of the time doesn't make sense. But we can do stuff like this. We can actually use expressions in our update syntax. So what's going to happen here is we're going to match everything because there is no condition, there is no where. So we're just going to update the entire company table. But what's going to happen is for every cell that we selected here, this expression, experience plus 1, will be evaluated separately, individually. So experience 9 will get a 1 added to it and will be stored back. Experience 5 will have 1 added to it and be stored back, and so on. So the result will be this. It's basically an increment. And what's interesting is that in most databases, this particular operation will be atomic as well. So it will either happen or it will not happen. You do not have to worry about locking. You do not have to worry about transactions. You do not have to, you just do it and it will take care of everything. Right, so those are our data manipulations. We showed how to insert stuff, how to delete stuff, and how to update stuff. But really, this is not the interesting part of, because just storing stuff is not, the strength of a relational database. What we're going to look at now is, how to retrieve stuff from the database. And the basic syntax for selectors is just that. Select something from something. That's simple. So for instance, we can do that, and we're going to get back exactly what we had in the database. We're going to get the entire spreadsheet, more or less. Right? A star in all databases denotes every single column that is in the engine. Now, of course, we can say that we don't want all columns, we want just a particular set of them. This will work. We just say select this column and this column from this table, and it returns what we see. Now, we're going to talk a little bit about aggregate functions. What are aggregate functions? It's when you want to run, just like in Excel, when you want to run a function over several rows in a particular column. So for example, you can count how many rows there are in your spreadsheet or in your set, whatever. Or you can get an average of a set of values, or you can get a minimum or a maximum. And those are pretty much the only ones that are more or less standard across the entire landscape. Everything else, you might be able to use it, you might not. It depends on your vendor, more or less. So for instance, if we use the max function, it is going to return us one result. It will again be in the form of a spreadsheet, but what it's going to have is going to have only one column and only one row, because we asked for a single result. We basically said, give me the highest experience in the entire company and return it to me. And if you notice here on the top, the column name is max experience. Now, why is that? Because we asked for a function, but we didn't name its output. And the database will normally just say, well, this is what you asked me for. This is how it's called. And if we want to change that, there is a standard keyword called as, which is an alias or an assignment, or however you want to think about it. The very same query will return the result in such a manner. So now your column actually has a reasonable name. Now, this usually would not be important because as a programmer, you know exactly what you asked for. So you know what the first column is that's coming back and what the second column is and so on and so forth. So this name looks like extra information that's just there to, to make things look nice. However, further down the road, it will become important. Now, we talked about aggregate functions, like maximum, minimum, and so on and so forth. But what if we want to identify groups in our data and return the name of those groups? The basic syntax looks kind of like this. We're selecting something from something, and then we group by a particular criteria. The criteria is just a set of values. These values might come from a column, these values might come from a function, or anything. An example. From the very same company that we used, we're going to get the department column, and what's going to happen after that is we're going to ask to group by the values in this column, and we're going to get this result. So if you look at the data we have here, what happened is we got the department column, but every single duplicate got compressed into just single value. So we got 3 values back. Now, who can guess what will this return? We're asking for 2 columns. We're asking for department and for experience. So just like before, we have 3 distinct departments, and we have experience all over the map. And then we say, say it again?
3 rows.
Yes, it will be 3 rows. And what kind of experience will it return for each of them?
Random.
Precisely.
When it chooses.
Precisely. In fact, most databases will not let you run this query as it is right now, because what's going to happen is the engine will look at this data, it will throw this away because we're not asking for it, it will start collapsing, for example, this set into a single entity, and will go, well, those are values that I have no way of reconciling. I don't know if the person wanted the smallest one, the average one, the highest one. So on MySQL and SQLite, this will just give you a random answer back, depending on insertion order, depending on the phase of the moon, depending on a lot of other things. You will get something, but it will not be what you expect. And Postgres, Microsoft SQL Server, Oracle will just say, depending on the language,
It's just using a random aggregate function.
Well, yes, but there is no such function as random for a column selector, pretty much in any. Yeah. So I guess, see, for some people, it's a feature. Exactly. So this will not work because, as I said, it will not be able to collapse those values to something definitive. And another thing that we would want to do with this set is order it, because while it seems logical that you insert your data one after another, so you write the first row, you write the second row, you write the third row, it would be coming out in the same order. But this is actually not guaranteed in almost any database, including things like simple single-user database like SQLite. Even there, if you insert 1, 2, 3, 4, you're not guaranteed that you're going to get 1, 2, 3, 4 in the same order back. So if you care about your order, you have to specify it. And the criteria are the same as order by. So, as group by. So it is a column, an expression, or a mix thereof. And this is how it looks when you order by experience. So we get our employees, but they're ordered by numerical values. And an interesting thing pretty much about any database is that order by will work both for alphanumeric and numeric values the same. It also applies for greater or smaller, and it applies for pretty much anything that has to deal with order. You can not care, just like in Perl, more or less, you cannot care whether this numeric value or whether this string value, and it will do the right thing. So let's put everything that we showed so far together. We have this query. We have a selector that has a single column, and then it has an aggregate function over a different column. It names it. We have a condition, everybody with experience less than 9. We have a group, so we're going to compress some of the rows. And then we're going to order by another aggregate, which we selected higher up, but this time we're going to turn it around. So by default, order by orders ascendingly. With desk, it will order everything the other way around. This will return what we expect. So first, the condition is executed on the entire table. This row is thrown away, and this row is thrown away because they don't satisfy the experiences less than 9. Then we get to collapsing the set that we got to something. So we're left with 2 rows in the Java department and 2 rows in the .NET department. And then, given those subsets of data, we are running the max experience function on them, and then we're ordering by the value of this function as well. And this is what we get. Pretty simple stuff so far. Now, to recap how all of this works, and this is important in terms of when you build complex queries, you always have to remember that this is the order. It varies from time to time, but this is generally the order in which your query will execute. So always your condition will fire first. It will be, in a sense, a horizontal filter. It will throw rows out this way. And then it will collapse stuff horizontally, which means that if we have the same values, it will compress them down to a single subset. Then it will order them, and only then it will see what it actually wants to vertically select in terms of column slices out of this data. And at this point, if you decide to select stuff that could not be collapsed by the group by that you specified, if you specified one, at this point you will get an exception. But other than that, everything else will work the way you expect. And there is another piece of extra sugar, so to speak, which is called having. And what it does is, after all of this is taken care of, it basically takes an extra where condition over here. And what it will do is it will, after everything is collapsed and after everything is ordered and after everything is selected down to the columns and the rows that you wanted, it will run an extra condition on top of that. Normally, this is not very useful, and I was going to show you later on, but this slide burned, so we'll see when we get there what we're going to do. And here I'm adding limit, which is a lie, because pretty much limit will work only on 2 databases of the entire landscape that there is. And because we'll definitely have time, we'll look into what other limit dialects are out there in the wild and how it actually, how bad can it get. So let's do another quiz. What does this select given our, here is our data set. What does this return?
Everything. 42.
Okay, everything meaning what?
All the rows.
No. It returns 42 how?
So return it one time for every row.
Precisely. Precisely. This is what it is going to return. It is going to give you 42 on the top, and it will kind of look just like everything else. That's why it's qualified as call name, because we did not give it an alias. So it will call the column 42, and it will return 42 for every single row, because as you saw earlier, what's going to happen is we get the source, we apply this, which doesn't exist in our case, we apply this, which doesn't exist in our case, there is no order, and then it goes and says, okay, I'm going to select those columns. There are no columns to be specified. We just say, select me this constant, 42. But the amount of rows is still 7. That's why we actually get 7 42s back. And this consists on pretty much every database. Now, this is a constant, right? Well, that's not very useful. What if we want to do an expression in there? How will it work? And actually, it does work. So what we do here is we select an actual column, and we select a function, a count. Now, if you go back to how things work, this stuff is executed before your selector. That's why it's very important. So what's going to happen is we get our set of data. There is no condition, so we don't do anything. Then we collapse it by department, Java, .NET, Perl. Then we go back and see what did we select from this set that we are holding right now. So we selected the department, which is already collapsed, so there's no ambiguity, so we can give that back. There is a count function, and this count function is going to run across every little subset in this group by. So what we're going to get is we're going to get how many developers are under Java, how many are under .NET, how many are under Perl. And then the last selector here is going to be evaluated again for every single row. But it does not really refer to the row in any way. It is basically just a select count from company. So what's going to be is for every single row, it will evaluate to the very same constant, more or less, of how many rows totally are there in this set. And this is what we're going to get back. Now, let's say we want to get even crazier and we want to see how many distinct counts of subgroups are there in our database. We have nothing better to do. So what we can do is we can take more or less this query, which has one source and has one selection, and shove it into a source for another query. So what happens here is this. Again, going back to our little table, we first have the source, and then we apply all the other stuff. Well, in this case, oops, In this case, we first need to find the source, which is from, and there's an expression here. So we're first going to construct this expression, which will be a count of every individual department contents. So in our case, it will be 2, 2, and 3. And then what we're going to do, we're going to make another query on top of this set, which is kind of doesn't exist anywhere, but it is a virtual table with one column called CNT. And this is where the actual aliasing becomes very important, because up there, on the first select, you have to refer to what you're picking out of this result set that does not exist anywhere. It's not a table. It's not, it's not nothing. It's just something in memory at this point. And this is how we're going to pull out the column that we're interested in. And then again, we're going to group by CNT, so the 2, 2, and 3 will fall down to 2 and 3. And this works down to more or less unlimited complexity. Now, it will get slower with every single wrap and every single extra permutation or extra collapse or extra condition that you put in. But in general, if you're not dealing, on the order of hundreds of thousands of rows, you are actually pretty safe to do this kind of more complicated reporting kind of queries on your data. And it will normally perform reasonably. By perform reasonably, I mean you will get your answer in under a second most of the time, no matter how much stuff you stick on top. And remember when I said that there is no standardized limit for databases? There are some databases that don't have any kind of keyword to limit the result set whatsoever. And in these cases, we use this. This is a monster query, which actually is not very efficient whatsoever, but it will work universally on any single database. So let's pick this apart. We have our initial result set, which is the one we want. We basically want to get every single column out of our company, but we want to limit it to just the top 2 rows. Now, how we can do that? We have to, first of all, figure out somehow how to how to order what the first 2 rows actually are. So we need some kind of criteria. The criteria in this case is employee. So the employee is the name of the employee is unique, and we can always order the result set by it. So what we're going to do is we're going to get our source, look at it, and for every single row in it, do a horizontal filter, which is a where. Now, this where is an expression on its own. And this expression will be evaluated for every single row one by one. So what's going to happen is it's going to get the first row. It's going to see what is the count of employees that are smaller than you. So for the first row, it will actually return a 0. There will be no employee in this table that will be before you. So our selector here is that basically we get everything from the company where, whoa, sorry about that. We'll get everything from the table where there is nobody else in front of us. We'll get all the count of all the employees that are in front of us. So for the first one, the count will be 0. For the second one, the count will be 1. For the third one, the count will be 2, and so on. And at the end, we say, for every single row where this expression is between 0 and 1, go ahead and return the stuff. And we will actually get the 2 rows back. Right. Let me see. Shit. Right, this is this is where my slide deck ends, and we have, damn, we're 20 minutes short. What we could do is I can show you different limit dialects as they're implemented by DBIc, or we can move to questions, or if you're entirely bored of this talk, we can go and get coffee. I'm really sorry this deck went down. Yes, go ahead.
Is there any way to force having to be able to consider a condition that is not already selected? Like, is there any way to apply a second, like have it act like a second where you want to?
So you're talking about, where were we? Sorry. So in this set, you're asking whether you can.
So you have a having clause. Is
yes,
only
which will be another
applied to the select.
another where. Well, it's another where here. Okay, and your question is.
So is there any way to can you do a having with a subquery? Like in other words, you haven't selected it, but you want to apply the condition.
The condition of.
You want to so when you do a having, you can only act on stuff that you've already selected.
Well, yes, because this is what it sees. We are already here. So we basically did our collapse, we did our order, we did our vertical selection. You can, of course, select extra stuff, but this will be the same, it will kind of behave the same like this.
Right, can you select extra stuff and have it not come back? You don't want it to come back. You just want to select something just for the purpose of applying a condition to it with having.
Well, then what you're going to do is this. You're going to wrap an extra query and get your selection, vertical selection, down even further.
You're going to put it in your from? What if you already have it?
You're going to put your entire set that you have with the extra columns that you had to select for whatever reason, for your order or for your comparison condition or something like this. And then what you're going to do is you're going to get this entire expression and select less stuff to throw the extra stuff away. In fact, in one of the limit dialects, we have to do that. We have to wrap an extra selector just to throw the stuff away, which we just use to order things before we say, OK, this is where we cut our set. This is our limit. Does this make sense?
Yeah, it's harder to get back to that point because I had this problem of trying to do crazy DBIc things, and I would have to battle between where and having, and I don't think I had the opportunity to get back to there, but I don't remember specifically exactly.
Right.
But I just remember.
But this is basically a universal way to do what you're asking. If you have too many things in your set, as a vertical set, you just wrap it in another query, and this part is actually pretty performant. Now on MySQL, this might become a problem. And MySQL, even though it is not the best engineered database, it is the most prevalent database. I mean, it's kind of like PHP.
The same. So if I were to in that select there from select count as CNT, and then comma foo as foo. After that, when I do a having, I can say having foo is, and it'll see the foo symbol that's within that subselect.
It will see it here. It will not see it out here. It will see it here. Damn it. It will only see it on this side. It will only see a having here will only see what you selected here. Because having is applied, again, having is applied here. Your vertical filter already ran.
But then you have no hope at that point of having a fast query. It's just going to be a brute force.
Yes, that's why you try not to use having in general. You pretty much answered your own question. Right. Any other questions? Do we want to look at the various limit dialects that exist in the world? All right, let's do that. Right, here they are. So, all right, so limits. Again, our selector, and at the end, the limit is normally applied after the after everything, after the vertical selector, after everything. It's the last thing that runs. This is what I showed you kind of in the slide as a pseudo. You know, this kind of stuff exists. This is only understood, you know, clean, simple, understandable syntax. Limit by that many and offset by that many. So for example, if you want to skip the first 3 and you want to get the next 5, you will say limit 5, offset 3. Simple, straightforward. Support only by 2 databases in the world. Nothing else will run on that. MySQL, a little different. Unfortunately, sufficiently different that you cannot use the top one. You have to drop offset, and you have to reverse them. And if you don't have an offset, if this thing is 0, you can drop it. So if you say limit 5, it behaves like the top one. But if you have an offset, you have to use a different syntax. MySQL, Postgres, SQLite, fine. Oracle, Microsoft SQL Server and DB2. And in general, this is the ANSI standard limit offset dialect. So this is actually part of the standard that supposedly every RDBMS needs to be able to understand. It's not understood by nothing besides those 2 databases. We're not even talking about Microsoft SQL Server in general. We're talking Microsoft SQL Server 2005 or later. They will run with that. So how does this work? And this actually is exactly your question. What we have to put our original select in the very, very beginning. And then we say, select everything from that, but in addition, give me a magic function, which is basically a number starting from 0 and going 0, 1, 2, 3, 4, 5 for every row. It's kind of like the crazy thing with the correlated where that I showed you earlier, but this is built into the database and supposedly is more performant. So what we do is we get the number for every row in this set. We give it an alias, and then we say, get me again everything without this number that we just prepared, because the user didn't ask for it. The user asked for 5 columns. They didn't ask for an extra like dangling 0, 1, 2, 3, 4, 5 set of numbers. So what we need to do is we need to generate this number, then make another selector so it can be thrown away. But before it's thrown away, there will be a horizontal filter which will check and return only the rows which are between our offset and our limit in terms of indexes. So that's how that works. It's not as bad. But we go further down. Skip first is a variation of the limit. It's something that's only supported by Informix. Again, just syntax. And another interesting thing, instead of having the stuff at the end of the query, here we have the stuff at the beginning of the query. So if we're dealing with bound parameters in DBI, we actually need to make sure that we put them in the right place of the entire execution. First skip is for Firebird and Interbase. Can you spot the difference? Select skip offset, select first skip offset. Just reverse the argument order. There is absolutely no difference whatsoever, but you have to detect whether your database is that, and neither of them will understand the other's dialect. Go figure. Ronum, Oracle, and this one's a fun one. So this is kind of like row number or over. So again, a magic function that we select, and then we throw it away, and then we do that. Now, why don't we do the between thing? And the between thing is shown here. Now, this is how we do it in row number over. And it's pretty straightforward. But why do we have to do that? Because on Oracle, this will be about 5 times slower than this. Well, then you would ask, why don't we just do this all the time? Because what happens here is that we ask for the index once here. So basically we say, get me this set of rows and give it an index from 0 up for every row. And then, because of the Oracle optimizer, we say, compare it to the function again. What's going to happen here is if the set is unordered by something else, if basically this set right here is not ordered stably, Oracle will return in the same statement on the call of this function once and twice, it will return completely different results. So the first subquery will be ordered one way, it will be limited, and then what it returns after that will be completely mixed up for no apparent reason, and we're going to apply our bottom limiter to a completely different set, and we're going to get back garbage. So that's why we actually have in DBIx specifically, we have to detect if this piece in here has a stable order based on our metadata, and decide which one of the two we're going to use. Welcome to standards. And when there is no offset, it's easy because there is no way for this duality to happen. We're always going to run row num once. And that's how that works. So that's Oracle. That's another interesting one. Now, you remember Microsoft SQL Server over 2005 supported something that's ugly, but at least works. Now, this thing is a variation of this, except it can only say, give me the first that many of a set. It does not have a way to support or to express an offset. So what do we have to do? We have to get our original query. We have to get everything from the zeroth row, all the way to the limit plus offset cutoff point. Then we have to reorder it the reverse way and cut it from the other side. But the user asks us for a specific order, so we have to reorder it back the way it came and then return it to the user. That's why we have select top limit plus offset, then order this thing in reverse, then cut off to the limit, order it again, and return the final set. That's Microsoft SQL Server under 2005. Now, does anybody see a problem with that? Besides it being slow and not very efficient, like anything raises a flag? Not really. OK. The problem is that imagine if we have 5 rows total. And what we ask for is offset to limit 4. What's going to happen is we get here. Offset to limit 4 means 6 rows. So we actually get the whole set. We reverse it. We assume that we already have cut as many as we needed, but we didn't, because the set that we asked for is smaller than the offset plus limit that we requested. So basically, we're requesting, it's like asking for a splice of an array that is smaller than the splice we're asking for. In Perl, it will just say, OK, this array is too short, so I'm just not going to give you anything. No. in the case of Microsoft SQL Server, what you're going to get is rows from the previous page, like completely unrelated rows, because there is no way by doing this reversal to know whether you need to stop somewhere, whether your set is actually complete or it's half of the second page, half of the first page, kind of thing. And all we can do is just warn about it, because there is just physically no way to detect that.
So they just didn't think about that as a feature?
Well, either that or, you know, here are billable hours, and, you know, we can fix your application a different way, kind of thing. So,
how does this stuff relate to cursors? And that's like a separate thing to accomplish getting a page by page, right?
Well, a cursor will not help you with pages. A cursor is just a way for a relational database, or, you know, any kind of engine really, not just RDBMS, Mongo, you know, any kind of NoSQL, any kind of really network-based thingy will. Ooh, we're out of time. Cool. Any network-based thingy will basically give you a way to kind of asynchronously ask for more results. So while they travel on the wire, you can do something with the first set. So that's what a cursor is. But a cursor relates to one set. So you cannot just say, okay, chunk me this cursor into, you know, into sets or something like that. And actually, we are done. I already discussed this one, and that's the insanity that we have to deal with. So I guess we're out of time. Thank you very much, and sorry for the watch presentation.